Satnam, for taking the time out. I know you're going to be talking about anomaly detection today, and also have expressed an interest in giving some advice to the students about career prospects and so on. So I look forward to the webinar, and I hand over to you now.
Thank you, Sabudh, and it's really a pleasure to come back and talk to Sabudh students and participants here. It's a really great pleasure. As Sabudh said, I've been associated with Sabudh from the initial days. I know there was a gap of this COVID time, but I'm very happy to come back here on this platform and share my thoughts. So what I'm going to do is I will stop my video and I will share my screen, and so it will be a combination of presentation, some demo, and so many things. The theme would be purely industry perspective. See, I'm pretty sure, if you go and type anomaly detection, you can get, hundreds of thousands of articles. But my goal here is to sort of like, in fact, in anomaly detection itself, I have applied at least in, 4 different roles, 3-4 different roles over the time. When I started at University of Connecticut, I applied anomaly detection in detecting terrorist activities, and it was a completely different application. And then, when I went to General Motors, I applied to detect intermittent faults. So the applications kept on changing, and the way you formulate the problem, that kept on changing. But yes, it has been a theme over there. And now, in information security, anomaly detection is actually one of the, I would say, one of the pillar, I would say. But, there are many other things, but, one of them, especially the data science part of it. So what I want to latch on is sort of give a very industrial perspective on information security, what are the opportunities, and then also present a technical side of that as well. And give you also lots of pointers that you want to try out, where to get the data set, where to start, what to do actually, and to get a perspective, and to do a start from a zero. And this is actually something I sort of like, I learned it very hard way, in a sense. When I moved to information security area 5 years ago, you have to learn on your own, right? I went to the conferences. I was lucky enough to get paid, while learning. So uh, the thing is like, quickly grab the things, learn it quickly, and then contribute to the product. So this is a very unique experience, and I can bet, if you search on Google, you can't find anywhere such kind of content. And it is absolutely, I want to present this thing to Sabudh students, so that, like, they can get leverage on one of the topmost content, and then also ask questions, and they can leverage with this unique experience, and then latch onto it, and then make some progress. Okay, so I'm going to stop the video and go back to the presentation and combination of demos and things like that. And at any point, if you don't see a screen, or something like, you see there is some silence or something, because since we are all remote, right? So just tell it to me, and right, and so that I can make sure that all the sharing and everything is going properly. All right.
We'll be
So
sure to let you know.
yes, thank you so much. All right, so I'm gonna do what? Let me see here. Okay, I think I am all set. Need to share my screen. I want to share. Desktop 1 here, and okay. I'm sharing now. Okay, what is this? Okay, all right, just a minute. It's asking me some. Okay, let me see whether. I'm bringing up my presentation. So it should be.
Yeah, we can see it.
Oh, okay, glad. Typically, there used to be an option like, share everything, share all. I don't see here, it gives me an option like desktop one, Google Chrome, whatever. So you are able to see this particular screen, right? So
We are, though we have got a rectangle with
yeah, the
some
other stuff.
diagonals.
Yeah, yeah, correct. How about you see the full thing now?
Yes, yes, perfect.
Okay, and in fact, this might be the whole screen, right?
It is, yes.
Okay, sounds good, perfect. So, anybody heard of Solarwinds Attack? I know I'm starting with a complete industry jargon, but just want to get this more engaging. Anybody heard of it?
Not me.
It's okay, no problem. So not a problem. So why I'm asking this? So SolarWinds attack is something which happened last year, and it is sort of like equivalent of 9/11 attack in cybersecurity. So like the way 9/11 happened, right? That changed the whole world. But in cybersecurity world, the SolarWinds attack, which last year happened, it changed the whole world. You may have heard of WannaCry and so forth. That was like a ransomware attack, and many other ransomware attacks you keep on hearing. But why am I starting with the SolarWinds attack? Is because see, this is something which is like the state of the art nationwide attack. It's been told that it's been done by Russians, and the way it was done was, SolarWinds have a product, and in their development cycle, right, in their dev branch itself, they injected the malware inside the code itself. So now there's thousands of enterprises, including American government agencies, when they update the software, the SolarWinds software, they actually get these malware along with that update itself. So it's like when we have a Windows update, right? We we trust Windows update. So if Windows pops up and it says that, oh, it's time to update, right? What we do as an endpoint user, we just say, okay, go ahead and update, right? And the same thing which happened with enterprises, including all the federal agencies and so-called, right, all the CIAs, FBIs, and all the intelligence agencies and everybody, right? And they have this software and they updated that. Now, these so-called nationwide attackers, they were listening to the conversations, and they, with that malware, they were able to talk to the server, able to get another drop to the computers, and then they find out, okay, which computers are those they are landed into. Are they having a which privilege access, or are they admins? What kind of admin access they have? Then they started doing a lateral movement attack, and they went to many of those cases. They found that they reached up to the guard level. What I mean to say guard level is like a global admin level of for any enterprises, and from there they got an access to all the emails. And because their goal was not really to do any ransomware and ask for money, the goal was to keep listening and keep reading those emails, gather the data, exfiltrate it, and know all the inner secrets, right? Now consider this: so much of valuable information gone somewhere, and in the wrong hands. So this has changed. It has changed the whole world altogether. We don't know here, sitting here, but in terms of American cybersecurity preparedness, it has shocked everybody. Now, along with that, last year when we were all fighting COVID, we are all fighting COVID today as well. Um, for attackers, it is an opportunity. They basically have been carrying out attacks on hospitals, on universities, and on companies, and you name it. On every industry, they are doing the ransomware attacks and making money. So primary motive of all the cyber attacks is all about money, and the second thing is a nationwide attack, right? So some nation, it's sort of like a proxy war. You're not The war is not really done just like a Indo-China border. It's more like done on us at the computers and taking over that knowledge and taking over the IP assets. That's where the actual war going on, and we don't see that, but that's where the real wars are going on. Now, these are different motivations for doing cybersecurity, and we all know that, right? And not anybody is aloof of it. There are different. This just shows that, okay, who all got attacked with the ransomware, but obviously it starts with the Western world, but then it is coming to India as well, and a lot more cyber attacks are coming. In fact, you must have heard of the cyber attacks happening on Indian vaccine companies, because there are many nationwide attacks. They want to get the IP knowledge from the vaccine um producers, and they want to steal the formula, right? So it is a complex problem, and it is of interest of everyone, and this is where the world is changing. And now, in this digital world, when everybody is working remotely, there is a lot more attack surface, and attackers are using that for their own advantage. Now, if you look at any enterprise and we look at the information security problem, this is a very complex problem. And the way, I want to set this up because you need to get a bigger picture, right? If you're talking about information security for any enterprise, you're not just talking about endpoints. Endpoint means, like, the employees, or some vendors, like a third party vendors or suppliers, their computers. Those are not the only points, right? You have to also ensure the network security, application security, data. Cloud is the most recent one. There all the action going on. And in the case of Solarwinds attack, the attackers actually started from endpoints, and then they went into the cloud. So they pivot into the cloud, and they took over the Azure Active Directory and Azure Office 365 accounts. So the attackers are, way smarter than defenders. Not only about the smarting, it's all about, like, when you need to break something, it's easier to break, and it is very difficult to protect. In order to break, you just need to find a one hole, right, to get into some, just like for a thief, right? In order to get in, he has to find a one loophole. But then, in order to defend, you need to, close all 10 gates, or 20 windows, and you have to find out, okay, where all your jewelry is and where your assets are, right? So the same thing is with the enterprise security. It's a very complex problem. And as I said, well, I listed only 10 of them here, but this area is vast. Now, then you say, okay, wait a minute, Satnam, if this problem is so vast, then what have we been doing? We have been doing. It's a billion-trillion-dollar industry which is doing information security. Then what they have to offer? Well, so far they have, the security problems and threats have been evolving, right? And with those evolution of problems, the defending solutions are also evolving, but there are basic security controls like firewalls, antivirus, whitelisting, having a good password, and doing some user access control. Um these are like the very basic foundational stuff, and you can't say that, okay, I'm just going to bring an AI solution and I won't do this. You have to do this basic hygiene. uh, and it's just like somebody says that, okay, I'm going to put the I will not put the door locks, and I will just have a motion sensor at home. No, you obviously you have to put door locks, because there are thieves which are sort of like of low IQ level, and they will just they want to go from the front door only, right? But then there are sophisticated attackers, and there are more like entry level attackers. And the same thing is like for malwares. There are malwares, and also there are ransomware which are very basic, and they don't change the signatures, and they don't change their techniques so often. So for them, even if you just have your antivirus, it's only a signature based, it will do a good job. But then there are ransomware which keep on changing their signature within every drop, within every evolution, like every few days. Now for that, antivirus companies have a very hard time to cope up with that. And that's where you need AI and machine learning, because at least every new sample you get, if you collect that data and you train your machine learning classifier, then at least you can able to detect that particular variant. So basic hygiene, security controls you do need, but along with that, you do need the advanced stuff, which is the combination of AI and some new stuff. Now we will talk about the data first, and what are the different data sources, and then the use cases, because it's very super important that you need to understand. Because when I started, I had a hard time to know where the data is, what the kind of data is, and then what are the typical use cases. And in fact, I will share you one gold mine of use cases. It actually, when I started, it was I couldn't even find a single place where all the use cases are listed. But this is really a gold mine, and just hold on to that. That gold mine will be coming towards the end, the grand finale of the presentation. So let's talk about the security data sources. So data sources, we again, there are a whole bunch of information security areas I mentioned, right, within enterprise IT security. Let's start with the sort of the elephant of that, which is the network logs. Network logs are all so many logs from firewall, IDS, IPS, intrusion detection system, intrusion prevention system. I mean, these systems have been there from 80s, right? And they have evolved. And if you have heard of well-known DARPA anomaly detection challenge, you can look at that data set. That data set is still considered to be as a sort of a golden data set to challenge your algorithm, anomaly detection algorithm. So if you have come up with a new algorithm, or you want to say that, oh, I just want to try out, then you can just go to that DARPA anomaly detection data set, and then you try out there. And I have seen still, like in academic papers are using that particular data set, and it's still like 15 years old data set. That's a hard problem, because the enterprises don't share the data, and then in academia you stuck with the old data. Now there are few in I would say academia, they started their own labs, and then collecting the data, and then labeling it, and started sharing it. So one of them is Canadian Institute of Cybersecurity. Yeah, I think I will share that link with you guys. They have at least the most recent data sets on these IDS, IPS data set, which they have shared. And then they have labeled also. It's not about just collecting the data and labeling as well. because every time you just pose it an anomaly detection, it's okay, but then who's going to look at those alerts and verify them? Now, what are you looking at here is the problem with the network logs is huge. It's, the couple of years ago, 5, 6 years ago, we were getting this term of big data and all that. It's a very ideal use case for that. And that's where, if you want to look at for each entity here, each printer, computer, you typically want to make a baseline and then say that, okay, is there any abnormal activity on that? See, just for an example, I have been working from Bangalore all the time, but during the lockdown, I shifted to my hometown, Jaipur. Now you see some login activity happening from there, right? So if you have these logs getting analyzed, then it should give a message that, oh, we see a different login activity. Is that, are you the same? Or is there, somebody making an attempt to your account? So such kind of alerts getting, they can get notified to the SOC center. Now, in the case of network activities, you can see an abnormal exfiltration of the data or abnormal activity on a port, certain ports. See, for example, bit miners, right? Bit miners, for them, the bit mining is all about using somebody else computing resources and mining bits, right? And for that, they steal the computing sources and mostly on the cloud. And so if you have this network activity monitoring, then you can at least look for that if you have a bit mining activity going on. So that's a network log. Now endpoint logs, we are more aware of the endpoint logs because we, if you have Windows systems, I have Mac, but in the Mac also you have endpoint logs like a syslog or say file system changes or application logs, process logs, what all processes are running. It's huge, right? Now consider that you have 200,000 employees and each and everybody's data going into some data lake, and then you are monitoring that. And for each one, you want to see, oh, is there anything abnormal? So you will get ton of alerts, lots of alerts. But then you have to use some tribal knowledge, and along with the anomaly detection and some tribal knowledge, domain knowledge, you reduce those alerts. So these are like few use cases I listed here that there could be some ports which are could be utilized by crypto miners, and we noticed that there was a port number like 9999, and which is a kind of unusual, and it was there on in a data center for at least 5, 6 machines, and it when we correlated with the processes running, it turned out to be a crypto miner running over there. So you do find such use cases, but yes, obviously you need to have some machine learning along with some data science, along with some more domain knowledge, plus some some other technologies, like in our case we use deception, and then you find those sort of anomalies, or you find those crypto mining activities and things like that, abnormal activities. Now, authentication logs, they are super useful, like Active Directory. Now, attackers are going after AD predominantly because Active Directory is something like, a directory of the whole enterprise. You know who, what kind of access, who has, the golden assets from there, where the real where the data is, because the servers from there, and you can do like a some where are the weak links. You can start from some sort of curve roasting attack on some service accounts which is for a SQL server, and then from there you can go and pivot and do a lateral movement. So if you want to get some presence on that, you do need to look at the logs, and where Windows security logs are super useful. And again, the privilege user logs, PIM products, privilege user management, that itself is a big industry altogether. There are at least 8, 10 different vendors altogether. So this industry is vast. Now let's say, as a student, we see that, okay, you have talked to me about various data sources and so forth. Where should I start, right? And where do I see the data? And can I try out something on my own? So we'll get to that part, okay? So here we will do both things. One is like, like a Python code, our own sort of a homegrown code. And then the second thing is like using something like Splunk, which is also they have a commercial offering, and they also have a free version to it. And in Splunk, I have been going there in their conferences and giving talks and all that, from 2016. I have presented 3, 4 times in their conferences, and there are like some nowadays I think there are 15,000 participants, and they will have like some at least 15, 20 parallel sessions going on, and it's a big party. And yeah, obviously the party didn't happen last year, and and they typically do it in some Disneyland and so forth. So so now when I started 2015, 2016, so one of the thing what I noticed that, like, when you want to start something in a new domain, uh, you may start with the industry itself, because see, many of the material they will give it for marketing and so forth. But as a student, you want to start, then you start from that content itself and you try out from there, and then progressively you build your own. So in this case, I leverage Splunk for sort of knowing the data sources, knowing the use cases, and so forth. So let's get to the Splunk, and then we will see the Splunk first, and then I will also show you the homegrown code and that demo as well. Okay. So just a quick check. Are you guys there? Or how's everybody? Are you able to listen? Any questions?
Yeah, can hear you loud and clear. So no problem there, Satnam.
Okay, sounds good. Perfect. And what I'm going to do is I will be switching my screens. I'm going from presentation to the Splunk screen. And, if you don't see anything on the screen, just tell me, okay? Just a minute. I am just bringing it up. It is there on my browser. Okay. Okay, do you see the Splunk screen?
Yes.
Okay, it's a Chrome browser. Okay, right. So I can actually, yeah. So you also see my terminal, right, in the Mac
Yes.
OS, right?
Yes, yes.
Okay, so you get your Splunk enterprise free version and so forth. You install and things like that, right? And then once you have done it, I started all that, and Splunk started, and it's here now. There are different apps. You can go to their app store and you can install the apps. Now here is a gold mine. Okay, this is literally a gold mine, because when I started, I had no clue, but this was not there in 2016 also. They actually started this effort in 2018, and from 2018 they started as a marketing effort, but it has come as a very good educational resource, and I highly recommend that. And that is actually uh, it is Splunk Security Essentials. Okay, now what is this Splunk Security Essentials? I'm not advocating any product or any company as such. What I'm advocating is the use cases, okay? Because when you start something, you don't know what is an application, how do I do it? Because see, the way I have been working throughout my career is I'm one of an applied data scientist. I don't work on a theoretical problems. I mean, there are lots of guys, they get their own excitement. I get excitement from a problem. Until unless I don't see a problem, I'm just like, on my own zone doing something. But here, you see all those applications here. Security monitoring, you see 164 use cases. And, advanced threat detection, you see 208 examples. Insider threats, you see 85 examples. Application security, you see 11. Okay, and these are all like, being talked more from the data perspective. Now, there are lots of things which are non-data perspective, but these are lot from data perspective. Now, if you come to the security monitoring, there are like out of these 164 examples, I can bet at least 90 to 95 cases you can look at from an anomaly detection perspective. See, for an example, it could be anomaly detection, or it could be domain roles as well. But then you can certainly do it from anomaly detection. And I have one or two other links on anomaly detection in security, which are like sort of gold mine. And I will share all those links, after this presentation. So now let's look at, these 164 examples here. So here, see, detect excessive user account lockouts. See, for an example, attackers do brute force attack, right? Now, if there is some brute force attack being done on some particular user, right, and you are getting the logs, then you can monitor those logs and you can see if there are any excessive accounts, any excessive counts. Uh, you can say, okay, what's the data science in it, right? Well, first of all, you need to get the data, and then you make a rule-based system only. But then after that, once you start doing a baseline of each and every user, because you may get some lockout for certain times, you may have forgot the password, but how many times? 2 times, 3 times, or something like that, right? If something is happening excessive time, then you will say, oh, there is some attack going on, right? But until unless you are monitoring those logs, you cannot flag it, correct? So let's just click on, probably the logs will not be there, but I'm just clicking on it. And now it will also talk about, okay, here, detect, step one, try ES content. Okay, because it needs, one more product from there, but let me try. So Splunk has a one more, product, and they have integrated with that, and so they are saying, oh, go and get that product also. But there are use cases which, which does not need, which can give you the very basic data set here, and then you can see that also. So okay, yeah. So another thing you will notice that there is something called MITRE attack tactic and MITRE attack technique. So this also you can look it up. This is, fantastic place to start your journey, because MITRE attack tactics and all these, they will tell you what are the different attack techniques are there, why attackers do it, right? And now out of that, they also tell that how can you detect that. So it's very interesting. And from there also you can get the use cases. So yes, so data sources, you see in this case, the data source is a Windows security log. So you need to get the Windows security logs forwarded here, then you will be able to see those examples. So, how do you get the data input and all that? I'm not doing in any Splunk class here, but, definitely you can, learn it, lots of it. What I wanted to reach out to you guys here and tell you that what are the different use cases possible, and there are hundreds of them which are possible, even in just itself in security monitoring. And then if you look at insider threats, then there are some other 208 examples. So 85 in insider threat and 208 on advanced threat detection. So you can get and look it up, and then you may need to do some data setup to see that data. But let me show you another thing where you can see the data and you can see the anomaly detection as well, and you can try it out as well. So here we come and Splunk machine learning toolkit. So I want to do one, again, I'm reiterating on this fact. See, for a rapid learning, I always, for any new domain to learn and all that, it's okay to start some with the commercial and some free and quickly learn that domain. But overall, once you get to your problem, these problems, you will not be reinventing it. Excuse me. Yeah, so you'll not be reinventing the tool, and definitely nobody's going to give you money for making something on the top of this or like that, right? You're going to be writing something brand new stuff and solving a different problem altogether, and things like that, right? So here, in order to learn, this is a fantastic place to start with. Now, detect outliers, right? You want to have an examples in an information security area, and which you can apply anomaly detection, right? So come here, detect outliers, and there are some examples, right? Now you have an example in security, like detect outliers in a Bitcoin transactions, or detect outliers in number of logins, or predicted values. So we can just click on this for now. I mean, because the Bitcoin, you can see that, okay, in the case of Bitcoin, this is a some sort of a random data they created, and um, and from here you can basically say that, okay, what you see here is, first of all, with the actual data will be the logs, right? And Splunk actually does the indexing and parsing, and it extracts the fields out of it and then makes the structured data. So I will show you that when I show you the Python example. I'll show you that structured data and structured data. In this particular case, this is a structured data which is being extracted out of unstructured logs. And then you see the from user to user, what are the different, I believe these are like, some bit transactions going on, and some fuzzy, some random values they have populated, and then they are saying that, okay, how many outliers are there, right? uh, you can get into which algorithm and so forth. You can apply their toolkit also they have given. I can show you, where you can also try out something. You can change the mean standard deviation, very basic stuff, right? And you can sort of get into the feeling of, okay, if you apply the outlier detection here, uh, then how many anomalies would come, right? And here it is showing. So this is a case where it is detecting the outliers, and it applied the sort of this value for a median absolute deviation, how much should be the threshold value, and what should be the sliding window. So these are all UI, and you can try it out on your own and then see uh, how that algorithm behaves and so forth. This is like sort of the very basic stuff for anomaly detection. All you're doing is, in this particular case, you have some sort of this is sort of like a time series data, right? So you want to look at, you want to apply a sliding window, and in this sliding window you want to figure out how many outliers are there, right? So you can apply different approaches. You can do very simple thing that, okay, what's my mean standard deviation, and then I compute some histogram, and then if there are outliers, some 3 sigma, 6 sigma, or whatever, 9 sigma, you can just give that value and then say, oh, if it is beyond that, then that's my outlier, right? Basic stuff. And the only problem it may be that it will give you lots of anomalies, and then you will end up having a false positive as well, and you don't have so many security analysts who are investigating those. Because see, if you get these many anomalies and you expect each guy in your security operation center to look at, oh, why am I getting so many login attempts from this particular computer? And it may be that there is some script which is being kept on running, and that script has been trying it to log in. So many things can happen. It could be false positive also. So so you can get a very good sort of a hands-on tryout equivalent in this Splunk machine learning toolkit as well. And again, third time disclaimer, not advocating any product or anything, it's for learning. Okay. So now let's get back to our Python example, which is homegrown, our own stuff, and we want to see some application there of anomaly detection and sort of security data science. Okay, all right. So I am getting back for a minute. I'm going back to the presentation, and then I will go to another VM where I have the Python code running. Okay. So yeah, I think I will get to that. Before that, I want to just briefly talk about that unstructured structured data, right? Can you just see my screen? I just want to confirm because I switched on between the two screens.
Yeah, it's visible. So you're showing a kind of some data here, simplified by.
Yeah, log processing.
Yes.
So all the information security, data what you see is actually in the form of logs, and logs have they don't have a structured form. They have either some JSON form, or it could be some key value pair. And this is a one example where you see some key value pair like this one, right? You have certain fields like host PCI domain, host is expected, host, that's an IP address of that host. Then there are certain fields like SRC, source priority, what is the source port number, and so forth, right? Or SSH protocol, what's that protocol? So that's how you see, that's how you get the data in security logs. Not get, actually, that's what is a typical form. It's an unstructured data, and it has a key value pair. It's semi-structured. You really don't need to do any NLP stuff here. You can have some indexing and some rule-based indexing, and you can extract key value pairs in certain cases, or you can define some template, and based on that template you extract it. So all these different tools which are log processing tools, like the free ones are like ELK, or it probably has changed something now, but Elasticsearch, Logstash, and Kibana, and so forth. It has evolved. I think it is called something else now. So you can use those log processing tools, and Splunk also, which will actually index that data, and it will extract into a structured form. So that data which I just showed you, right, and that data is now extracted into a structured form, and it extracted those fields, right, those fields I was talking about. So that source destination, that IP address, from that source destination, in this case it is actually a sort of a network activity. So now which protocols are on which protocol that activity is going on, right? You can look at those that activity and see, oh, if is it an abnormal or not, right? So that's a one use case. But what I want to highlight here, that unstructured data is getting converted into structured data, and that has happened over here. Now there you apply the anomaly detection. What do you mean by that? Like, okay, you see what is the typical baseline behavior, and if their behavior get changed, then you flag it as anomalous, right? Yeah, different themes, right? You can apply some clustering based algorithm, DB scan. You can apply one class SVM algorithm. So there, my take on that is like, when you come to the real world, many of those algorithms, they don't perform well on a big data issues or where you need a streaming fashion. I have seen the more like T digest kind of algorithm, which is looking at more, which can be parallelized, which can do some parallel computing. You can do a parallel computing as well, and then they can look for extreme outliers, and they are good on integer data and floating data both. They work very well, and those, and they also have been implemented in Spark. And so you can actually, if you do on these some of these large data sets, you can apply there. So we will look at the T-Digest demo in Python example. If you look at as such a class of algorithms in anomaly detection, the one I showed you, right, in a Splunk, where you look at, okay, just look at a window wise and then compute some histogram and some density, probability density function, and then you can see, okay, how far it is from standard deviation, how many sigma it is away, and then you can say it like, baseline, and then from the baseline how far it is. And that's like an outlier detection thing. You can also pose it as a semi supervised or novelty detection problem where one class SVM comes into a picture. Uh, you can also pose it as a supervised anomaly detection where you tag it actually. You tag it, this is anomaly, and I want to find out that. Actually, that works out pretty nice also in some of the use cases. But the only thing is like the effort of tagging is huge. But if you will see that, there are companies which have become just for tagging itself, they have become a multi-billion company, multi-billion dollar company. There was a recent one which were tagging the images for deep learning applications, right? And that itself is a industry altogether of tagging. I haven't seen a tagging industry in security because that is a very, very tribal knowledge. You can't just tag it, oh, here is a log, and for this one it will be always like that. That doesn't work in security. No, so here is a particular example we want to see. Just one use case I picked up from that Splunk security essentials, right? I showed you that 400, 500 different use cases, correct? So one of the use cases, like you want to look at the data exfiltration. Is there any exfiltration going on? So this is a domain knowledge. So what these network security guys, what they said, let's monitor this particular ratio. And this ratio is you compute what's source application bytes minus the destination byte, and then you divide by the total of it. So sort of like you are looking at that, is there any exfiltration going on? If there is a lot more data going out, then this PCR ratio will show me that, okay, yes, there is a lot more. There could be an exfiltration attempt. Again, that there are it itself, like it takes years of knowledge to build a product only to do that. Because if you do it for hundreds of thousands of devices and you look at first of all, how do you collect this data? Then second thing is, how do you make that baseline for each one of them? And then when you flag these anomalies, uh, how do you say whether those are really a true positive or a false positive? And then how do you collect the feedback from the analyst? So, but as an academic exercise, let's look it up and let's see whether I can detect those anomalies and so forth. And my recommendations here is if you have a smaller data, DB scan is fine. But if you go for a larger data, T-digest seems to be good. And middle, you can use also kernel density estimator. That works also pretty good. So the web logs, these are the logs which you use it for detecting this. And here is a visualization in a PCR. So this is a Splunk screen, and you basically write a query. Just like in a SQL, you write a query. This is a Splunk query language, and in Splunk query language, you are just writing a query here that you give me the stats of bytes in, and then bytes out, and you're looking at that. And for each source destination, you are looking at that, and then in this case, you are looking at for this particular source. So if there are more bytes out, then there could be some exfiltration attempt. That's what this particular screen is trying to tell. So we apply a T-digest algorithm, and T-digest algorithm is invented by Ted Dunning, one of the smartest guy who actually was involved in a MapReduce as well, invented that, and he's a chief architect at MapReduce. And so this is motivated from just one directional KNN algorithm. And you are making, you basically start with the different clusters, right? And then you say that, okay, yes, is the new point coming, should I merge with this one, is it closer to this or closer to that, right? That's just a one directional clustering algorithm. And based on that, you basically you start. The good thing is that you can parallelize this, right? So you started with, you can say that, okay, yeah, these many clusters I'm going to start, and I'm going to merge them. And then if I have any extreme values, I can quickly compute those quartiles, and I can compute like I can figure out, okay, how far are they, and they're how extreme they are, and I can quickly find out that. And that's where the T-digest is super powerful. So let's see that in action. So what I have, I'm just switching now into, okay, let me see. Can you see my screen?
Yes, but it's kind of blank right now. Yeah, yeah.
Okay, that's
Yeah, we can see it now. We can see it.
Okay, it's a virtual box.
Notebook. Yeah.
Okay. So I just had a setup, all the setup here on a VM where, that particular Python version and all that, everything is all set up here. So I just, I'm just using this for the demo. So, well, if in the actual thing now you want to do it, how would you do it? I would say that you do it in a Kubernetes, and you do it in a container, and then container is much easier to ship it and to share it and things like that. Well, this is some time back I did it. So so the bits are here. Now I have already a Splunk setup, and I ingested the data, and data is already there. And actually if I can show here in a Splunk. Okay, I think this will be a very skip up. Okay, the font size may be very small, correct? Right.
It is a little small, yeah.
Yeah, I know. This one is very, very small. There's some, yeah. Okay. Yeah, somehow it is not responding also to my. Okay. maybe somewhere. Okay, so what I'm trying to say here is that the data is already there, collect web data. That data is already ingested here, and the logs, from those logs, Splunk has indexed the fields, and with each field it has converted into a structured data. So here you see all these fields and their values, what the values are. This is just showing for one particular log line. Now what we will do is, okay, the patterns, statistics. Okay, so each log line, you see lots of fields like that, and then with these fields you make a table, right? And that table is the structured data. On that you will be making the anomaly detection algorithm. So we have the data in Splunk. Okay, now this data we are analyzing it. Okay, let us see
So
that.
Satnam, this isn't purely unstructured data as such, right? This is
It is
essentially a
semi-structured.
web log. It's
This
yeah.
is
Okay.
semi-structured.
Okay. Cool. Okay. Fine.
Correct. Okay. Okay, where is my this? Yeah, this is here. Okay, now I'm just trying to get to my other screen. Okay, here. Do you see the Jupyter screen now
Yes.
here?
Yes. Yeah. Yeah.
Okay. So the way it is starting is basically, yes, you import bunch of uh, Python packages, and then the important part is that the data is there in a Splunk, right? So you need to have some Splunk library to talk to it. So we have a Splunk SDK. With that Splunk SDK, we are able to get the data. So there is an Splunk IO, Splunk data provider, and that's the class we have used from Splunk SDK Python, and we are using that to get to make a call to Splunk and get the already structured data. Because see, we don't want to reinvent the wheel. In this particular case, the all the indexing and everything is done in Splunk, and we are just getting the structured data here. Um, you can use any other tool. You can use Elasticsearch, Logstash, and there are a whole bunch of other free tools also. You can use those also. But I'm just for giving one example here.
So this data is open source, though, is it? I mean,
Yes,
or if you
yeah,
have access to it
data,
because you are a
exactly.
customer. Okay. So open source. Okay.
Data is open source, and in this particular one, like actually we used a Splunk that I was showing you, right? That is Splunk Security Essentials.
Right. Right.
They had given some sample data also, some
Wonderful.
random data.
Uh-huh.
So we just use that random also, and we also tweak it to create our own random data because we wanted to have anomalies.
Right.
So we created something our own to create the data also.
Sure. Sure.
Yeah. So yes, that's one of the biggest problem in security is like nobody shares the data. So
Right.
but the Canadian university I was telling you, right? They have started sharing some data, and which is very useful data actually.
Mm.
Okay, so here is I have a function get PCR frame, basically getting that structured data into a data frame, and then I'm making that pandas data frame, and I'm gonna do the t digest algorithm on that and flag the anomalies, right? So so here you see that, okay, I'm just showing a simple histogram on that, and then simple box plot, and then showing that, okay, yes, when I run the t digest algorithm, it is flagging the anomalies. It's a very, very primitive toy example, but something to sort of get a, your own starting of and trying out something in a security domain, sort of. So, I'll be happy to share the bits and, share some data and all that stuff. I'll share and I'll send the whole material in my email, and, you guys can try it out. Students can try it out. And this is just a one example, right? On this one, you can, write your own bits and write your own different set of algorithms and, go about it. So this is one example I shared here, which is talking about one particular use case. And there, if you want to look at, there are 400, 500 such different use cases, correct? So what I'm going to do is I will get back to this thing. Okay. All right. Okay, so I will get back to this stuff here. So we talked about the various use cases, and I showed you one demo as well in the exfiltration detection. And so pros and cons of security, I already talked about the security data science. It will flag you lots of anomalies, but you don't have that many analysts to look at that, right? So how do you use the domain knowledge to flag those anomalies and reduce those and make it more informative, correct? Then just a learning path. So I'm pretty much done with my tech part of it, and this is just something I put together as a sort of mind map. If somebody has to start and reading all this machine learning, data science part of it, where to learn, sky's the limit. You can keep learning, but a bunch of courses and all that. I have listed few things here. For foundations in machine learning, data science, look at Tom Mitchell course, Udacity, Caltech. All these are, fantastic free course, free stuff. You guys know a whole bunch of things from Python stuff, stats, probability. Definitely, it gives you. You need to have a strong foundation. So this way, you need a whole bunch of things from Udacity, Stanford on statistics. Good thing to learn from there, and something to know all about the big data as well. So lots of things over there as well. So yeah, look it up on a mind map, and I think that's pretty much it. I think I'll take the questions, and maybe what I can do is go back to the Zoom and I can start the video as well.
Sure. That's great. Thank you, Satnam. There's a fairly long question by Ravinder from Badusab, but I think you kind of answered that. He was referring to the fact that you've been talking about Splunk, you've been talking about Elasticsearch, MapReduce. It becomes daunting, right, for an undergraduate that's starting here. I mean, what's the minimal set that you think the undergrad needs to be able to really start making some impact, from a data science perspective?
Yeah, so, okay.
And Ravinder, if I'm rephrasing your question incorrectly, by all means, please do unmute your mic and ask the question as well.
Okay, can you see me on the?
Yes. We can still see your screen. So if you want to stop sharing the screen, then unless you want to go back to some bits there.
Yeah. Is that fine now?
Yes, perfect.
Oh, okay. So yeah, hi Ravinder. So yes, I do acknowledge that there is a whole bunch of things. I sort of compress that information. Also, starting from these ELK, Splunk, and many things, right? So I'm more of a practical guy. So I would say that, like, say, if you like this information security area, or you like the log processing, you want to work in a B2B domain, um, then definitely you pick up this area, and your time and effort in learning this will be very much valuable. So if I get a two resumes, one who has done some app and some development in Splunk, and who has also tried out this security use cases, and he comes to me, and then there is another guy who comes, just for an example, and there's another guy, who is also good academically, but then he has never tried anything on his own, or he tried in a something in some toy example in e-commerce, or something in a say, let's say, in a Swiggy food recommendation example. If that kind of resumes comes to me, I will not pick up the latter one, right? I'll pick up the one which is security examples and who has tried the Splunk thing, right?
Mhm.
So it all depends on, if you sort of like start thinking, Ravinder, where you want to be. So in that case, I'm just telling you, here is a gateway. Sort of, I'm just telling you the gateway to these log processing and the security areas, and not just security, like any B2B log processing areas. You can actually start with this, and if you start with these tools and do the development there, I'm pretty sure you will very quickly you will end up getting your first job.
Right. Ravinder actually is a mentor at Badu Saab, so he's actually helping a lot of the kids there. So this is kind of
Oh, okay.
he's hoping to get your insights to be able to kind of actually
Yeah,
help
so in
kids.
that case, what I see is that there are lots of applications, right? So when we get to the log processing and the B2B use cases, right? So if we start with these, then you can able to analyze those use cases and see if the way I showed you that is Splunk security essential, right? And I may sound repetitive, but just tell me a place where you can get a 500 use cases.
Right. No, that's incredible actually.
Right,
And
how can you get a 500 security use cases in a one place, right? You won't get it in any academic newspaper, academic paper, or something like that. You won't get it anywhere, right?
hmm,
And plus, like, they are doing it for their own Splunk app store and all that. We don't need to, we have to think broader, right? And then take it as a learning, and then see, all those security use cases also. I don't need to focus. I need to focus on where I have a customer, right? Where somebody is banging on my door with this particular problem, and I see this use case which is also there. I can quickly go and grab and that knowledge, and then get it up to on my feet.
right, right. No, great. Another question from Adnan actually was, I think when you had started talking about the unstructured data, you were saying, are there certain, Python libraries that are typically used in cybersecurity for structuring the unstructured data? Or is it basically get down to the basics of understanding what is the data, and then, write some kind of your own script to break it down into the pieces you need?
Yeah, there are different log processing tools. There are companies which are doing that, and this is a solved problem. I don't think we need to spend too much
Hmm.
time onto that.
Right.
There are Python libraries doing that as well. I haven't really ventured into so much of that, because Splunk is our investor.
Right, right.
And so we have a partnership with Splunk, and so
Keep
we
that to
don't,
them.
yeah, we don't need to deviate so much.
Right, right, right. Great, thank
Yeah,
you.
but there are tools, and there are libraries available. It's a well solved problem.
So I don't know whether this is specifically, in your domain as such, but he's in the general digital forensic space. Prem is asking, how do you use anomaly detection there? Prem, I guess digital forensics is a very wide subject. Would you want to clarify a little more about what specific kind of use cases you have in mind?
Yeah, so see, what I know, digital forensics is more like, see, when these our red team guys, right? When let's say you want to know after the fact what has happened, and well, it could be for a crime scene as well. It could be for an enterprise also that there is some machine which is behaving, inappropriate, or this is due to some crime scene, or maybe you feel like there is some intrusion has happened on that machine
Right.
because of you get some initial alert and then you want to see it. So what typically done over there is that you start with there are a bunch of tools like which will do the memory forensics, and they will look at what are the different processes, and they will try to load the memory into us, and then you have to look at, okay, which are the processes that have been running, and are there, they have a signature related to some malware or related to something, some sort of like say I would say like some known signature or a known knowledge you try to look for. It's predominantly rule based stuff, and then you try to latch on to that. And then many times it could be also you try to correlate with the threat intelligence knowledge. So let's say you are working in a bank, and then you are doing this forensics. So now okay, what are the recent malware attacks happened on some particular bank, or one branch of it, or a different branch, or a different bank altogether in that time frame, right? So you look at what are the different exes and the processes were involved in those malware activity or ransomware activity. Now you try to see that here. So there, you may want to do some digital forensics. So uh, so that is also, there are tools and companies, they do all that. And if there is an interest on that, just remind me and I can send you those links and I can point you to those tools.
But again, I mean, from a digital forensics perspective, also, I mean, if you do have data, of the past, right, and you again, anomaly detection is a very important tool there to be able to say, look, something is different here, right? It's basically looking for behavior that is different from the norm. So would that be the typical kind of?
So it will be a use case, but the only problem is that, like, after the fact it has happened, right? You don't have a baseline for that. So like, you got let's say you got a machine which you think like, there is some malware, there is something running on it, right? But you need to have a baseline when there it was not attacked, right?
Right.
What is the difference. So either you have a baseline from a different host which has the same operating system or similar set of applications running on it. You
Right.
get that baseline, and then you compare with that for that particular host. And that's what the typical UBA companies do it, user entity and behavioral analytics. That's actually again, there are a whole bunch of companies which will actually position it as they are doing the advanced anomaly detection problem. In the digital forensics case, you already know that this is a machine I have, and I don't have anything onto it. I don't have anything else. I only have this machine. Tell me what is wrong.
Right.
So that is where I am getting into. Let's say it is more like, there is some crime scene also on that machine.
Right.
So you want to know that, oh, are there any wire transfers were done or something? Is there anything, running very fishy on it? What is that running on it? Tell me, what is that?
But again, I mean, can't you look at the time series? I understand that you don't know when the event occurred where this machine was, taken over and was being used for something fishy. But I mean, over time, would you not be looking at where behavior suddenly changed, right? Suggesting some suspicious activity started at that point, I guess, and trying.
Yeah. So you can. No, I'm not denying that fact. I'm saying that that is a different class of tools which is called UBA.
Right. Okay.
Okay. And I'm just saying that there are two different industry segments,
Huh.
which is always the one which is always analyzing this anomaly detection behavior, deviation into that, and then flagging it.
Right.
That is called the user entity behavior analytics, which is always doing online. And you need to have agent install on each and every machine, and then it will tell you that.
Right.
But what I interpret when you say, Satnam, I have a machine which is like, it does not have any agent, it does not have any UBA and all that stuff. It has, but I know this machine is bad because I gave it to some vendor or something, and I know that it has corrupted or somewhere. But tell me, what is wrong here?
Right.
So that is where I'm coming from. In that case, you don't have any of that data with you.
Right.
And now you have only sort of like you have a corrupted machine, and you want to do some forensics into it.
Right. Okay.
So there it's a different set of tools and algorithms, not algorithms, it's more like a domain knowledge only. They will look at which process triggered which process. They look at the process tree, and then with that process tree they try to see, oh, okay, is this process being a known signature example of a malware or that kind of an activity.
Right. Okay, great, thank you. I think we are questioned out here. So Satnam, thank you. I think what I'd like to do is get a project set up using that open source data that you were talking about, not necessarily the Splunk data, but the one that you had said there's a large data set that the university has made available.
Sure, I will send that data. Yeah, I'll share the links of that.
The links for those, and then we can get students to do some pieces of work, and I'd love it if you can come back and give your view on what the students have developed there at some point. Even kind of suggest some future case studies that they could actually work on with that data. That would be really incredible for them.
Yeah, the Canadian Institute of Cybersecurity, they have done a fantastic job. They have also linked with the papers published on that data set as well. So you can see how to leverage that. One of them was like a Tor, non-Tor activity.
Okay.
They actually labeled it and then say that, okay, is this browser traffic being done using a Tor protocol or a non-Tor protocol? So because many times attackers use it. This is like one example I'm doing it, but there are a whole bunch of other data sets which also have that. I'll send that.
Brilliant. Excellent. And to get to know more about Splunk, I presume the best place to go is the Splunk website, right?
Exactly.
Okay. Yes.
Yeah.
Perfect. All right. Thank you so much for your time, Satnam, and look forward to engaging in the future.